Let's consider the system's initial potential energy, V1. Block B is hanging vertically, and its potential energy is determined by its height. The higher it is, the more gravitational potential energy it has. Similarly, Block A on the inclined plane also has a potential energy based on its relative height to the ground. But how can we specify the height of each block relative to the ground if we have no idea how far the ground is situated from our system? Well, when referring to an object's height, we are referring to a relative quantity. This means that we have to define a reference point for each object before we can assign a quantity to its relative height. We know that block B will travel a vertical distance of 8 meters, after which the system will arrive at its second state. So to simplify this problem, we can define our point of reference for block B at this final location. This leaves block B at a height of 8 meters above our reference location, which allows us to obtain an expression for its initial potential energy. Since blocks A and B are connected by a rope, we know that when block B moves 8 meters downward, block A must also move 8 meters, but along the incline. However, for gravitational potential energy, we only care about block A's vertical displacement. And to calculate this, we'll use trigonometry. Since the incline is at an angle of 30 degrees, the vertical height block A moves is given by h sine theta, or 8 sine 30. As with block B, we can use this height as our reference point. We now know what the vertical distance traveled by block A is between states 1 and 2. But remember, block A starts below its reference point, so its initial height relative to the reference point is negative, which means its initial potential energy is also negative. We now find the potential energy of block A as 25 times 9.81 times negative 8 sine 30. And finally, now that we have the initial potential energy of both blocks, block B is positive and block A is negative, we can add them together to obtain a formula for the total initial potential energy of the system. By substituting the respective values, we find that the system has an initial potential energy of 1,765.8 joules.